Hey guys, Dr. Brown here, and tonight we're going to look at the derivative of tangent x and prove that it does in fact equal secant squared x by using the limit formula. So let's get after it. Okay, so we're proving this right here. So you'll recall that a derivative using a limit is a limit as h approaches 0 of f of x plus h minus f of x all over h. So we're going to use that particular thing on this one. So that would equal tangent x plus h minus tangent x all over h, and that is the limit as h approaches 0. Well, what is tangent x plus h? Okay, there's a little formula out there. So we have the limit as h approaches 0. It's a, what's the name of this? It would be just the sum difference identities associated with trig functions. All right, so this would be, just looking at tangent x plus h, that's tangent x plus tangent h, now that's not hyperbolic, that's just tangent h, divided by, obviously we have h, but there's 1 minus tangent x tangent h. Without the h, that would be what tangent x plus h is. But it's all over h, so I'll put a h here, minus tangent x. It's also over h. So I've kind of separated the two. And the reason for that is now I need to get a common denominator. So let's multiply this other side by 1, but my 1 is 1 minus tangent x tangent h over 1 minus tangent x tangent h. Okay? So that was my 1 I'm multiplying this by. So we have the limit as h approaches 0 of, all this is over h, 1 minus tangent x tangent h. Okay, so I have tangent x plus tangent h minus, now I'll distribute this, tangent x times 1, so it's minus tangent x. Negative times negative is positive. Tangent squared x tangent h. So we can immediately reduce on the numerator, tangent x minus tangent x, that goes away. So what are we left with? We're left with the limit as h approaches 0 of tangent h. I have a tangent h here and here. Let me factor that. So tangent h times 1 would give me this tangent h plus tangent squared x. So if I multiply this, I get that term. Multiply tangent h times tangent squared, I get this term. Okay, what else is left? So we've got this and this out of the way. All right, I'm back over h. And then let's finish out this denominator, 1 minus tangent x tangent h. Okay, now then, what is 1 plus tangent squared? Secant squared. So I'm going to move this secant squared x to the outside times the limit as h approaches 0 of tangent h over h times the limit as h approaches 0 of 1 over 1 minus tangent x tangent h. I probably didn't have to do this last step, but to me it makes it a little bit better. So I have secant squared x times the limit of tangent h over h. What is that limit? That's 1. So I have secant squared x times 1. This limit, as h approaches 0, this term becomes 0. 0 times anything else is 0, so I have 1 over 1. It's 1. So I have secant squared x times 1, which is what? Is secant squared x. So that, my friend, proves that the derivative of tangent x is secant squared x. I would encourage you to noodle around on some of these. Try the sine x, cosine x, and just work through those. They're fairly simple if you find the product to sum identities. So, all right, good luck with that. And why are we doing this? Together we're trying to build a better tomorrow and do that through math. That's all for now. Keep studying. We'll talk to you next time. Thanks.